Salam guys, how are you all? I hope you are doing well. Okay, let me share if you want to share your screen, because today lecture is lecture 7, and in this lecture we will study about your designs, okay, whatever you have done. Okay, so yes, who is first and who want to present first? Dear Mohammed, do you want to show anything?
Okay, brother Sarush, Assalamu alaikum wa rahmatullahi wa barakatuh.
Walaikum assalam.
I will share mostly three paper. I will not take time. I will share slowly, and I will concentrate about something because all of us are specialists in the science. Shall I share?
Yes, please.
Everybody, you see my screen now? Not yet?
Not yet.
It's okay?
Now you need to present your screen.
I presented, but I don't know what happened.
Maybe your network issue, or maybe you have slow network.
The sharing button, I think it does not work.
No, it is not working.
Yes, it's working now. Yes, I don't know what happened. It's okay?
Yes, it is presenting.
It's presenting now?
Yes.
Okay. Actually, this paper which I introduced, my first paper which I introduced, it was presented in EU CAP in 2018. Actually, at this time, I maybe one year period to this paper, I was start working and researching about the ultra wideband antenna and how to enhance the bandwidth of this antenna to become a super wideband antenna. For that, I do many trials, I do many researches also. Also published period to this in MS, this is Mediterranean Microwave Conference. It was in Turkish. And I start by very simple design, this normal design, but I try to reduce the size of this design, as you see, because I'm using the Visio here to introduce my design. I use a normal feedback, streamline feedback. I don't use a coplanar at this time. But in the back of this antenna, I make a trapezoidal shape. The size of this antenna, it was very, very nice and appreciated in the conference at this time, maybe almost 4 years ago. And they said, I have a comment from the reviewer. They said, this size considered like a novelty at this time, maybe 4 years ago. Because the size, it becomes 30, the length of the substrate 35 and also the width is 23. This is a primary result because I work in it. I will show to you now quickly after I present this one. Of course, I introduce a reference antenna, the first step. After that, I add the slot, and after that, I cutting the lower edge of the patch. As you see, you can see how it is different from each other. This is, of course, the parameter picture coefficient. Also, this VSW, and also I introduce some radiation pattern about this work. Also, I add some work. Of course, I introduce also the maximum gain. You see, the maximum gain is almost around 5. This is a final design.
Yes.
As you see. Also, I want to increase also my research. For that, I do. Of course, we have also. As you see, of course, it is working from almost 2 gigahertz, 2.5 gigahertz, till maybe 21. But the problem, as I said, is how to compromise this with the radiation efficiency. If you have a good gain, you may lose the efficiency. This is because this is a normal equation. You can find in EM box. For that, we need to find a solution. We need to compromise this problem. Also, I work also in time domain for this kind of antenna by investigating the group delay, face-to-face scenario. I made 4 scenarios. I'll show you now quickly, and also this is a group delay. All this made in simulation. Later that I start writing a complete paper for the journal paper about this enhancing bandwidth of the planar ultra-wideband antenna and using also for investigation also time domain performance. This is a step of the antenna as usual, and this is also the I make something like optimization for every part. I optimize to get the good result. As you see, there is a difference here. Okay. This is the ground trapezoid slot, and this is the optimized dimension, and also I get the final result. Also I fabricate it. I could fabricate it, but also I can only measure the S parameter. For that, when I measure, I found the result become like this. You can see till mostly the range of the ultra wideband. We can say the simulation result and the measurement result they are agree with each other in a degree. But after that, you can see the very big difference, or we can noticeable difference between the measurement and between the this is a measurement by red light, solid light, and this so that this is this is a simulation result. You can see that you can see this difference still maybe 21, but still the antenna working. Of course, I investigate also about the surface current. Actually, I was interested. I was talking about the radiation pattern because I found it is a very good thing for the antenna. You must be careful. This is I estimate by simulation, of course, because I don't have the test chamber for measuring it. For that, I investigated the co-polarization and the cross-polarization. As you see, the cross-polarization maybe in E plane almost less than 40. Yes. Or maybe less. It was very good antenna. Yes. And also for the H is less than 20. As you see, almost in all cases. Of course, by increasing the frequency, we have a distortion in the H shape or the donut shape for the E and H respectively, because this is a normal thing. This also is again, and this is of course the total efficiency and the radiation efficiency. You can see the total efficiency and the radiation efficiency, but mostly there is no big difference. Yes. Between both of them. It's also by simulation, but I was interested also in the gain. The radiation pattern is good, and the gain also is good. You know, by increasing the frequency till near 20, we can almost this point almost 5.5 gigahertz. Yes. Yes, and also I investigate more about the time domain because also I am interested in the time domain. I do the experiment. This is experimental work with the measure with the simulation result with the time domain because it's part of the S parameter measurement in as a magnitude also and as a phase. You can see the linearity of the phase between each other. Also, I investigate about the signal itself. I could estimate the group delay. After that, also I go to I measure the signal. Also, this all by simulation. Transmitting and receiving antenna in different scenario, face to face, side to face. It's a 4 scenario, as everybody knows. And also after that, I investigate about the normalized spectrum density because I want to mask it with normal power spectral density for the ultra wideband. And we can see it is covered all the range of ultra wideband till also the maybe 21 or 21.5. And also I estimate the signal fidelity. The signal fidelity, as you can see, it is high in the scenario. Almost all of them, maybe more than maybe 85. More of them in all cases. I estimate this one. This is one of our considered complete paper after the conference of EUCAP. It was in London, 2018.
Did you publish this paper?
This one we don't publish actually because we face a difficulty because you know EUCAP actually they suggest us to submit it to the IET. You know.
Yes.
When we start writing the paper, we found most of the data is written in the paper. We face very big difficulty about the plagiarism.
Mm-hmm.
This is actually it was one issue. Even we have new result actually.
Yes.
I quit working in it maybe 1 year ago. Actually, this actually yes.
Yes, this is because of this reason.
Yes, yes. Another thing actually, second year actually, of course, because we have difficulty for the measurement and for fabrication. You know, this fabrication and the measurement, it takes from me almost from 3 to 5 months.
No, it
Yes,
fabrication
yes,
measurements do not take much time, but here it is very
yes.
fast.
Yes, for that we start working in another thing. Actually, me and my colleague also thinking to modify the antenna shape, and we can have our own shape. For that, we submit a paper in EUCAP the second year after that, EUCAP 2080. And alhamdulillah, this paper also is accepted and presented. Actually, we have our own shape, the normal shape, and we cutting the spot behind the feet by different scenarios, as you see, and we could get till maybe 35 gigahertz. And also investigate the directivity, investigate also the gain, also the radiation pattern. But also the facility of the measurement and publication was difficult for us at this time. The year after that, maybe 2 years ago, we ending working. We decided ending working about the ultrawide band because also we publish a paper. Video to the paper also we publish a paper in the same year in Springer in wireless personal communication. It was a good paper. Alhamdulillah, take long time for publication also and submitting and revision. For that, we try to submit a paper to Teleconomica, this Scopus Indonesian journal. For that, we try to use our same. We try to investigate another type of ultra-wideband antenna, and we try to make some notches. Because we saw some people they make a notch maybe 10, maybe 3 or 4. We try in this paper we make a 5 notch. As you see, this is our own design.
Yes.
Actually, we have a strategy in our design, and I totally agree about this strategy. If you design a simple shape, and this shape has a small modification, for that you can control the optimization easily. This is one of our targets. Actually, it takes from us almost maybe 3 weeks, really, to optimize all these parameters as you see, and all these routes in the partial ground. And also we try to use the equation, and also we try to use optimization, and we make a comparison both of them. Of course, this is the evolution of the antenna design. This is of course the first design, second design, and the final design. This is optimization, or the steps of the optimization for each one, and we could get this kind of 5 notch, as you see. Alhamdulillah, this is accepted almost in maybe less than 1 month. This paper, of course, we make a comparison between our work, and we conclude this also in the discussion of the conclusion. This is maybe considered the last work for us in ultrawideband. But also I start working ultrawideband almost maybe some months ago, and I make a design. But this design, the main of this design is not for ultrawideband. It is only for the MIMO antenna. And in the time of the MIMO antenna, I will show to you the result, because I am still working, writing this paper. Actually, for that, I will show to you the result only, not the shape of the antenna.
Okay.
And we can discuss if you can have idea. Sorry for taking a long time from everybody, and thank you for your listening.
The previous paper that you have shown me, you can try in AEM journal. Maybe it will be accepted there if you don't want submit in IET journal.
Actually, IET journal, I have experience with it for the transaction of the antenna propagation. Actually, it takes 6 months, and after 6 months, they say a comment about the measurement or something like that for the reviews. Even I try to put 2 simulation results from HFWS and CST, and make a lot of results. or the time domain investigation or something like this. They said they reject because of the measurement after 6 months waiting.
No, I mean AEM journal, Advanced Electromagnetics journal.
If you suggest a journal, please send me the link, please.
Okay, I will send you on the WhatsApp. Okay.
Okay. Thank you, brother. Sir.
Okay. Good luck. Okay, dear. Another one, please show me that are sending me their results on WhatsApp. Dear Saf, did you do anything? Okay, Tariq, before presenting your screen, should ask me, okay, because maybe some other people wanna present and you presenting.
What? I can't hear you.
Wait a minute. Now you can hear me?
Yes.
Okay, I mean, before presenting your screen, you should ask whether I should present or not, okay?
Okay.
Because some other was, I was asking to Saf first, okay, then I will ask you, okay? Dear Saf, do you want to say anything?
Yes, I do multi-design. I will see you here. I will show and get some result.
Mhm.
So it starts from narrow band and to start to end ultra wide band.
Okay, show me
So
screen.
I will show.
Yes.
Yes. It's sharing now.
Not yet.
I think the share button is not activated. I don't know why.
Maybe it will take some time, as Mohammed did.
Brother, you can push the screen shape. You have a screen shape on the left side. You can push it and after that you can share. Because it's become late. Yes, it's okay now. Yes, now it's okay. So, do you see my design now?
I am watching your screen, not your design. You open the CST.
Just a minute. I open, yes. But I will share another option. Yes, okay. Now sharing now?
Yes.
Yes. I get multi-simulation for multi-design. So I started with this design, or the first design. So I get this result as one here. So here is the wideband, as you see, but I need to shift the frequency. Maybe it's maybe the component or the antenna maybe scale up to increase it, to decrease the shifting frequency. This is the main idea. And for this design, I will show this.
I think yesterday you show us the same design, right? I saw.
Yes, but I modify something about it. I modified by the here cutting from here. If you see it, I have to get more wide band. This is the first option, and the second option I get this also. I get wide band and more increase it by change something about it. I change the size for that. Maybe it's the very near, not appear difference, not big difference. So another option, I use its hat here. I put hat here to see. I get new results. So I get more wideband and get shifting frequency from here, because if you remember, it started from 4, now it's 30.5. After that, I get another simulation here. Not much, but it's the band here in the 7 is the disappear. So I get I get put some I cut from here and this side to increase band and shifting. After studying the surface current, I cut it from there, and also I made some change from here to remove the upper part of the CPW. Okay. To get, and after that, I many try for that. Okay. And here I make some shifting from frequency here. I cut it from there and cut from there. I need also a new result. So the total result, I want to see something here. This one. Yes, that one. Also, I get more. Just a minute. Yeah. Also, I get cut the half circle here, and also get new result. I will. So I will see the total all the design here. Which one is recommended to me to fix it and shifting frequency. So I get many results here and save it from graph of the design here. Yes, if you look at the wideband, the both wideband that you have achieved, its return loss is not very good. Okay, because it should be less than minus 15 dB. Okay, in all of the cases, you have very less return loss. Okay, I mean it should be more deeper. Okay, in the downward direction. Yes. Maybe it's up to 50 or 40 or more than 40. It should be in the range minus 25 to 40. It is okay. Yes, maybe enhancement by use some enhancement surface material or meta material. Yes, we can try with metamaterial, but first you need to set the frequency. You can set the frequency at 3.5 gigahertz. Okay, and you should know what is the show me the design first. Okay. Okay. Which one? Maybe it's 9 design here. Yes, you can show any design. Okay. Press one button on your keyboard. Yes. Press 1. Yes. Okay. Zoom it, and you should know the reason of your circular slots inside the CPW. Okay. Yes. You should notice the change. If there is no change in the frequency band, there is no need to add circular slots in the CPW. Okay. So remove because not big effect, not get big effect at the antenna design. Maybe I remove it and maybe. Okay, show me the first design with the enhanced CPW. Excuse me, I didn't hear you well. Show me the first design that you have shown me with complete CPW. I want to take a snip tool and want to share my screen. Okay, just zoom it so that I can take snip tool. Okay. Okay. And keep your design at near to the toolbar, near to the other side. Okay, on the left side. Okay. Left side. I mean, shift your design to the left side. Like this?
It's okay, it's okay. Let me share my screen, and I want to share some suggestions with you. Okay, can you see my screen?
Excuse me, no, just a minute. I will. Yes, now it's okay.
Okay, so you have this design. I first you need to know what is the difference in the results by adding these slots. Okay, if there is no change in the S11, then no need to add these slots. Okay.
Yes, I will remove it because
Okay.
not big change.
Okay, so you need to do some like I want to share more ideas, like you can modify your shape to because at this moment your design results are not very good. Okay, so you can do some steps in order to get more better results. Okay, like wait a minute. Okay, suppose you have this design. Okay, this one.
Yes.
And you have this shape. Okay, this is okay, this shape, this is your patch. Okay.
Yes.
Okay, the other thing, this CPW, you can use CPW in this okay, in this way. You can make a sharp peak. Okay, like this, and then go to this like this. Okay, so this is
Yes.
your CPW. Okay, and also on the same way,
Yes.
this is your CPW. Okay, now this is your field line. Okay, and what if you divide your field line into two parts to achieve the nullity aspects, like this is your field line. Okay, and
Yes.
if you divide your field line into two parts, one is here and like Y shape. Okay,
Yes.
in this way, as I show you my one paper, I think did I show you my one paper, or maybe I will show again this one as same as this one. You can see the field line is in Y shape field line.
Yes.
Okay,
Why shape? Yes.
so you can make a Y shape field line. Okay, but you need to connect a patch in that way, like if you you can make okay, remove this one, this patch. Okay, so you have a yes. Okay, you can make any shape here, like Z shape or S shape. Okay,
Yes.
you will get a dual band antenna. Okay, this is your first resonator. Okay,
Yes.
or it can be like this.
So here it's increase the length, increase the length of the wave length to shifting frequency to reduce shifting frequency, right?
Yes, you can make a resonator like this. Okay, and
Yes. I
it
think so. Also, I used the feed line here. All the total feed line I think is the 25, maybe not 30. So this is the reason of the high frequency.
not very high frequency, but acceptable. Okay, you should try this one, because I did not notice much change in the results. Okay, because of this one, or maybe because of this one. Okay, so try this one, maybe it will become I think if you try this one, then your design will be circularly polarized. Okay,
Okay.
because of this
Can you?
cut CPW
Yes.
and this Y shape, it will behave like a circularly polarized antenna.
Inshallah, I will do that today.
Okay, take a picture of this one design so that you remember and you can design it. Okay.
Yes, just take it. Yes.
Did you take the picture?
Yes.
Okay.
Thank you very much.
So try this one. Maybe it will help you to achieve, give you more better results than this. Okay. So this is
Okay,
a novel, good idea. So you can try this one. Okay.
Yes. Also, I want to ask about what about the background? Can I use some metamaterial or some shade for the background or
For
not?
the background, just forget the background for the moment. Okay, just first try this one. Okay, and then we will
Yes.
see what how is the results, and then we can decide later on.
Okay. Thank you very much.
Okay, good luck.
Thank you.
Okay, now Mr. Tariq, you can show the screen. Dear Tariq, can you hear us?
Hello, Mr. Ahmed.
Yes. Now you can.
I can share my screen.
Yes, now you
Can you
can.
let me?
Yes, yes.
Okay, now I can. You can please see my screen?
Yes, I can see your screen.
Okay. At first, I make this design. At first, I make circular shapes as a patch, and then I make a partial ground, and then I make semicircular here behind the feed line.
Okay.
And I see the result. I get some bend is above minus 10 dB. So I make quarters circular here at the edges of the ground, and I optimize the result, and I get perfect result. You can see my S11.
Yes, I can see your S11. But the problem is that there are a lot of patch antennas, circular patch antenna already published in the research. So we need to find the novelty factor, new shape or new design or whatever.
Yes, but this is from this work is actually 4 years ago in my master degree. I did this work.
Yes. Okay. Okay.
And
Yes.
and yesterday I tried to make this ground as coplanar waveguide, and see the result. I get just from 2.77 to 17 gigahertz.
Yes, this is UWB because it is behaves like a UWB antenna. But there is a no shape. I mean, no good shape. Let me share my screen. I will give you some suggestions. Okay, to do. Did I give you any suggestion in the previous designs you showed me?
No, actually I didn't because I busy yesterday.
Okay. I mean, I have given you. Yes. Okay.
Mr. Ahmed.
Yes.
For this work, what is the problem? We can't make optimizations or slots or any idea.
Yes, I am going to share you one of my design that is a circular, but you can see the design. I mean the design.
because this is very simple design.
Yes, you can see I also have a I made a simple, you can see I use this, this is already published. Okay, then I made this slot and then I created this slot and then made this final design. Okay, this final design, the left one, this one. Okay, in this way you can modify the shape to achieve more bandwidth. Okay, it can be 2 to 5 gigahertz bandwidth. Okay, or it can be UWB. Okay, depends.
Okay.
So in this way you can make your patch different. Okay, don't make a circular patch, I mean just modify the shape so that it will not be nobody can say like you have followed any paper and you made the same thing, not like this. Okay, because all simple circular patch antennas are published a lot. Okay, so that's why I want from you to make some changes in the CPW or make a different shape in the circular patch. Okay.
Yes, I actually I make a circular patch because it's my first design in CST. I didn't know many shapes and.
If you don't know any shape, you can even search from the internet that different shapes.
I mean, is 4 years ago. I didn't know shapes. Actually, I did randomly like circular shapes.
Yes, it is randomly, but you can, if you make slots like you have a circular patch like this. Okay, and you want to like suppose you have a patch, I mean substrate. Okay, this is your substrate and this is your patch. Okay, circular patch, and you can make some slots or you can make different shape. First, in order to design, you need to keep in mind what you want to do. Okay, like you have a simple patch like this. Okay, so how you can modify the shape, you can make some modification like you can, okay, what if you create a triangular inside the mid of this patch. Okay, like this.
But I think in this case I will not get super wideband. It makes slots.
No, maybe it's not necessary that you make a wideband or like this, but maybe but the most important is the novelty factor and the uh, frequency band you achieve and how are the results like this. Okay, maybe it will work as a dual band, but because of this circular structure it is surely wideband. Okay, but with this slot maybe it will behave a less wideband or maybe more wideband. You should try this one. Okay.
Okay. And the other idea?
Okay, other idea is okay.
In the ground plane or planar waveguide or.
Yes, I prefer to use the scope planar because maybe if you achieve some bandwidth, or maybe we will try with the metamaterial later on, or maybe we can uh, um, make it what is
I
you
want
say
to apply metamaterial at this design.
Don't apply it right now because the metamaterial you are applying is not like that. Okay, I will, when we study on the metamaterial day, then I will show you how can we design metamaterial.
Yes, because it is my topic now.
Okay, so okay, you need to make any shape. Okay, you can try any shape. Okay, just to first try with, or maybe you can.
And Mr. Ahmed, I will use foreground player or partial or coplanar wideband.
You can use this one, or one more thing. You can use one more thing. Let me share here. Okay, try here. Okay, so suppose you have a ground plane. This is your ground plane. Okay, Okay, and you want to modify shape, you can use this one. Also this is help you to increase the bandwidth. Okay, this is your ground patch, sorry, this is your ground plane, and also this one, and this. In some of my design I use this one. Okay, so you can try this one. Okay, if you vary this width of this strip line, this micro strip line, then your results will vary. Okay,
This will help me for what?
it may help you to increase the bandwidth. Okay, like this ground plane.
But in this design I get not good gain. Can I increase the gain?
Yes, you should try this one. It will also help you to increase the gain and efficiency.
Okay. Okay.
So try this one and tell me how will be your results. Okay, and then we can discuss later on. This is a good idea, you should try this one. Okay, because in some of my design I use this one, and it will help me to make the antenna circularly polarized or to achieve good bandwidth or circularly polarized. Okay, even if you get results at 3.5 gigahertz, then it is okay. Okay, just show me your results. Okay, and with the new shape.
Just tell me, Mr. Sarosh, at the range that I will use this design.
Okay, if it is if you achieve wideband, then you can in this frequency range it is acceptable. Okay, but if it is less wideband, then you can try this. Okay, 2 to 5 gigahertz. Okay,
so I don't care about 20 gigahertz or 30 gigahertz.
no, just leave it and set your frequency range from 1 to uh, 15 or 12 gigahertz. Okay, to see where it is working.
Okay, thank you.
Okay, you can stop sharing and turn off your microphone. And other one, Tjiraj, you want to show me anything?
Yes, sir. Wait.
Yes, show me. Yes, you are sharing screen now. Yes. Okay.
Sir, first of all, in earlier design, actually, I'm not didn't getting anything. I have tried a lot actually for this design. Actually, you have told me to go with the partial ground. I have designed the partial ground as well as this ring structure over here. Then again, there is no effect on the S11 parameter. Then I again optimize this CPW ground plane over here from according to its length actually. But still, I am getting the same thing. It will be resonating after 7 gigahertz, I think. And I didn't getting a proper result in this case.
Okay, show me the impedance.
Impedance will be 50 ohm.
Okay, now show me the design.
Yeah, this one.
Show me the back view. Is there anything on the back view? First thing, why you are using two ground planes in the design? You can
no, actually first of actually earlier I have just do the partial, go with the partial ground and then check the results. Then still the same issue is there.
Yes, you can use the partial ground. You can use a partial ground, but not near to the port. You see in the back view and in the front view you have the ground plane. It means on the front view you also have a ground, and on the back view you also have a ground. So if you want to make a defective ground on the other side of the substrate, then you don't need to make a ground near to the port. You can make it upper side of or mid side of the port. That's why it is not working properly.
Okay.
You are using dual ground.
What should I do to just shift the frequency band to the lower frequencies? is what can I do? Actually, I have also optimized it for the length of the patch actually from 27 mm to 33, 34 mm, but still getting the same thing, not proper result actually.
Yes, when you use CPW, then your CPW
Yes,
ground control your frequency band, okay, while your patch help you to achieve your desired radiation pattern, okay. So in this case your frequency is depends on your CPW, length of the CPW. If you increase the length or decrease the length of the ground, then your frequency will vary, okay. And also you can try with the less width of the feed line, okay.
Okay, that's good.
Yes, and also try to make another new shape, because this you can see this is a rectangular shape patch, okay. You just added a horizontal slot, okay. So you can, yes, you can modify some edges, like you make a triangular or circular slot on the edges, okay, to cut at the four edges of this patch, okay. And you can also make a vertical slot in the mid of the patch, okay, as you have designed the horizontal slot, okay. Yes, but if you create a vertical slot, maybe it will work multi-band antenna, okay.
Okay, one more thing, I have made a very simple patch actually. If any kind of suggestions you can give me to make it multi-band or wide band. This structure I just follow from the, I'm just getting the equations from the EN Talk website actually, and then I've just designed this.
Yes.
And according to this, I'm getting this one parameter is this. I have given a frequency range from 1 to 12 actually. Because in earlier design, I have given 1 to 6 and it will be resulting after 6. So that's why I have already taken a frequency from 1 to 12 gigahertz. So is it any possibility to do something in this insect feed patch actually to get something different?
Which CST version you have?
2018, which one you haven't shared?
Okay, okay.
The start of the program.
Okay. Okay, so for that, first you need to, before designing the antenna, you need to keep any shape in your mind, okay, or you can check on the website. Even if you don't know the shape, then you can go to the graphic designing website and you will see so many shapes there, and you can try to make a new one, okay.
Graphic design, sir, any
Yes.
name actually you can suggest?
Even I mean on the Google, if you write okay, if you you know how to cut the patch, right? How to create and cut the patch, okay. So okay, so I'm share my screen, okay, and I am sharing or not, okay, to give you some suggestions, okay. I think I also have some designs, or maybe I can share you some designs to work on. I made a lot of shapes in this folder and save the CST file, but I did not publish these shapes. So this is also a good shape, okay. You can make a shape like this, okay. There are 4 resonators, so it means this antenna will work at 4 different frequency bands, okay. So you can see here, you can create a shape of the patch like this, okay. Okay, you can see there are 4 patch here. Okay, I mean this is your resonator 1, this is your resonator 2, this is your resonator 3, and this is your resonator 4. It means this antenna will work at 4 different frequency bands. Okay, but not I mean like 1 gigahertz, then 2 gigahertz, then 3 gigahertz. Maybe it will work at 1 gigahertz, then maybe at 5 gigahertz, or maybe at 3.5 gigahertz. Okay, it depends. Okay, so you can use CPW technique. Okay, and make a shape like this. Can you create shape like this or not?
Yeah, yes sir, yes sir.
In the first step, what you need to do, you need to create a just simple patch. Okay, like you need to create a patch like this. Okay, I made a simple patch like this. Okay, and then what you need to do, you need to create a plus slot. Okay, this is your plus slot, plus shape slot. This is slot and this is your slot. Okay, and then after this slot you need to create a C shape slot like this. Okay, and then here C shape slot. Okay, and also here C shape slot. Okay, in this way you can create this shape. Okay, try this shape, maybe it will help you to achieve because this antenna is, I just set the range 2.2 to 3 gigahertz, and it is operating at 2.45 gigahertz. Okay, if you like to work on this design, the size of this design is very big. Okay, so I want if you can reduce the size, and this design will be publishable. Okay, so with this CPW you can I mean you can control the frequency band. Okay,
Okay, okay.
I have another idea in my mind, you can also do one more thing. Let me share. Suppose this is your design. Okay, and if you rotate this one like this. Okay, now okay, now when you are connecting the field line, I mean at this point it you see both patches are connected with the single field line. Okay, so if you
Yes, sir.
make a U shape field line like this. Okay, suppose you have a patch like this, and you can create a field line here. Okay, very small field line. Okay, and then you can make a U shape on the field line to cut or divide the field line. Okay, to connect this patch. Okay, like this. Okay, I want like this, so it will become a novel design. Okay, new design, very good design.
Yes, sir. I will try for tomorrow actually. Tomorrow I will show definitely.
And also yes, it looks very good design, and you can work on it. Okay, because in this way you will have two designs. Okay, or also I want from you, you work on it. Okay, leave the other design,
Yes.
just work on it, or if it does not show you any results, then you can create a slot here. Okay, to make it like this. Okay, then it will become two different patches. Okay, and really it will become amazing design, and a good journal can be targeted.
Okay, sir. I will try. I will work on this.
Yes, and you can use CPW here. Okay,
Brother Sarosh, excuse me, Brother Sarosh.
Yes.
Excuse me. If you want a parasitic patch in this U, but by small, it may have effect upon the transmission line or no?
If it connecting the transmission line, if it is not connecting, then it will not affect the transmission line. Okay.
Thank you.
Okay, so brother, did you understand, Tjiraj? Did you understand what I mean?
Yes,
in this way you can make a amazing design, and try to keep this design a very less size. Okay, and width of the antenna you can take in this range. Okay, from 20 to 30 gigahertz, sorry, millimeter. Okay, and the length, this is the width. Okay, and the length you should keep in the range 30 to 50 mm. Okay, okay, you can use FR4. Okay, because once this design is completed, then we will decide for which application we should target. Okay, suppose if it is made of FR4, then we will if it is made of Roger 5880, okay, then it will become a flexible design. Okay, and then we can discuss this bending analysis, and we can discuss that it is for wearable application. Then we can make this design for wearable application. Okay,
sir.
So you can use 5880. Okay, with the different thickness. Okay, 0.25. Okay, that is available, or you can use 0.787. Okay, you should use this one. Okay, because the frequency is it is not at millimeter wave band. Okay, so you can even use this one, or you can use 1.52 millimeter. Okay, you can use this one. Okay, this one. Okay, so take a screenshot of this design, this one. Okay, take a picture of this one.
Yeah, I already did that.
Okay, and you must keep in mind, I want size less, because a lot of research is doing and going, I mean, and they are reducing the size more and more, so we need to target less size. Okay, okay, so this is your task, and you need to show me on WhatsApp and other things. Okay, where you want. Okay, have you done the screenshot? Did you take the picture of the design, dear Tjiraj?
Yes, sir, I have take the screenshot of the paint actually.
Okay, so the next one, Ambresh, do you want to show anything, please?
Yes, sir. I have a design, sir. I have done a design.
Okay, show me your screen.
I'm sharing, sir. I'm sharing.
Okay, okay.
So whether my window is visible, sir?
Yes, it is visible.
Sir, this is the design which I have done for the first time yesterday. Like I have taken the dimensions of the first paper, the first task, but I tried to introduce the different shapes on the back surface, and I have cut the small part of the feed portion.
Okay.
And even I have added the coplanar ground structure here. So this is and the S11 for this result, this design is, I got this one, sir. But what I have done is I have only varied the ground plane length. Like initially I have taken the ground plane length to be of 8, wherein I got this blue color waveform. but somewhere it is going a little bit above minus 10 dB, sir. I could not get a wide band with respect to this. And when I decreased it still more, like for 5 mm, 9 mm, 7 mm, and 7.5 mm for length of the ground plane. But I could get the dual band characteristics. For ground plane length equal to 5, I got a single band, which is of this green portion, sir. This green portion. And for other like length of ground plane equal to 9, 7, and 7.5, I got a dual band. So this is the design, sir. The reference is impedance. Impedance is 50 ohm.
Okay, show me the design and leave the other results, because even that's one is not working well, but design is looks nice, so we need to make this design operational. Okay, so I give you some suggestions for that. You can work on it. Okay, okay, keep your design at a side, move your design on the left side. Okay, so that I can take a picture. Yes, yes. Okay, what is the length and width of this design, and which substrate you have used?
F4 have is 1.6 mm thickness. The first paper which I designed, no, sir, like for the first time which I showed you a paper, the length and the width have taken the same dimensions.
Okay. Okay.
Yeah.
Okay. Let me take a snip tool so that I can give you some suggestion. Wait a minute. This design is good, and I suggest you to keep this design save and work on it. Okay, to make it operational and to find the novelty factor. Okay, so how can we improve this design? I am sharing my screen. Okay.
So shall I stop sharing the screen, sir?
No worry, you can, if you can see my screen. Can you see my screen?
No, I'm not able to.
Okay, you can stop sharing.
Yes, sir, now it is visible.
Okay, so this is your design, and this is a simple monopole CPW fed monopole antenna. Okay, and you need to do the following things to make this antenna operational. Okay, first thing is that your antenna is I mean effective on I mean the radiation sorry, the S11 is effective of this CPW. Okay, if you increase the width of this one, wait a minute, if you increase this one, okay, in the upside, okay, then it will affect your frequency. Okay, because this one here you can see it is what we say a far distance from this field line. Okay, so the other main thing is that if you increase, like I use some other things, like you increase the field line like this. Okay, like this. Okay, so if you increase or decrease, check this one. Okay, do simulation for this one and check the results, what is the effect of on the S11. Okay, for this one.
Okay.
And okay, so this shape is good. Okay, and also try with the other one. Okay, in most of the cases if you are using CPW technique, then Roger FR4 do not give more good results than Roger. Okay, so you can use Roger 3003. Okay, or you can use Roger 5880. 5880, and you can use 0.8 millimeter. Okay, okay, okay. For this one, do you notice any change if you made this thing?
No, sir. I did not notice any change. When I changed when I removed the portion of feed, small portion of feed, I noticed that there was a slightly increase in the bandwidth of this antenna. And later on, I went through the changing the length, only the length portion of the coplanar.
Okay, so I have a suggestion for you. You can remove these slots. Okay, remove these slots, and you if you can increase the like this. Okay, if you combine, or you can start from here. Okay, this is your patch. Okay, and like this. Okay, make a patch like this. Okay, and check your results. Okay, this is just like this one. uh, like you have a patch here, and you have a smaller patch here. Okay, and you have a smaller patch here like this. Okay, it is like this. Okay, so you should try this one, and also create a SRR. Okay, SRR means split ring resonator. Okay, what is SRR? It is like this. Okay, this is slot and this is slot. Okay, so in this, in here you can introduce SRR. Okay, like this. This is a circular slot. Okay, so this is called SRR, and you, it may help you to increase the bandwidth or other thing. Okay, gain of the antenna. Okay, this SRR help you to increase the gain of the antenna. Okay, or in the other way, you can also do one more thing if you want. Maybe you can increase this length. Okay, in some way, like if you, this is just like a plastic elements. Okay, okay, equal in length of this one design. Okay, here. Okay, you need to do some optimizations. Okay, if you did not notice any change in the results, then remove this one, remove this CPW, and use the partial ground plane behind the substrate. Okay, you should use ground plane like this. Okay, on the back side of the antenna. Okay, do simulation and show me the results when you do. Okay, or other thing is that I have one more suggestion, that is good suggestion in terms of novelty aspects. You can do in this way, like you can remove this one. Okay, and extend it in the downward direction. Okay, extend this in the downward direction, and create another microstrip that connects the feed line. Okay, and also here like this. You will have three, like your field line is dividing into three parts. Okay, the first part is connecting this patch, the second part is connecting here, and the third part is connecting here. Okay, try this in your design. Okay, did you understand?
Yes, sir. Sir, if you can show me like how to do this, the left side of the arm which connects to the feed portion. If you show me once, I can try it today.
You,
And also regarding placing SRR, one SRR at least one, if you show me, I can try to this.
yes, you can even sorry, you can even use a U shape. Okay, like this, that connects this patch. Okay, and also this patch, and later on we will try to make this design reconfigurable. Okay, we can add diodes. Okay, at this point. Okay, at this point. Okay, first try this with this. Okay, we will try which nullity factor we can find here.
Okay.
Okay, dear Gaston, do you want to show anything? You can turn off your microphone, Ambresh. Okay, dear Gaston, you want to show anything? Dear John and the others. Today, very less people has joined the session.
Sir,
Yes.
can you show my design?
If yes, you want to share your screen.
Okay.
Okay, show me.
You can see.
Yes, your screen is visible.
Okay. And this is my design.
Mm-hmm.
It's not possible show in CST because I don't have CST in this computer.
Mm-hmm.
But I say my design in a PDF. But this is the shape.
Mm-hmm.
And I use the same dimensions of your paper,
Mm-hmm.
the size, the length, the width, and the thickness.
Mm-hmm.
First step, I put ellipse page.
Mm-hmm.
Later, I insert this slot in the feed line.
Mm-hmm.
Later, I put these circles in the left side and the right side, and finally put the circular patch in this side of the ellipse patch, and the result of the simulation is this.
Mm-hmm.
Later, I try to improve these results. I try to put this code. I put this part of the list page, but the result not improved. Later, I put a patch in the center of the ellipse path, but the result not improved, and I have these results. But you can
Okay, so show me your design and I will give you some suggestions. Okay, because this design is very simple, and with this simple design we cannot target a good journal, but I give you some suggestion to make some changes so that maybe it will become a good design. Okay,
okay.
show me the structure of your design. Did you try another design or only this?
Oh yes. This is my first design
Mm-hmm.
for
Yes, this one.
2.45 gigahertz.
Mm-hmm.
The size of dimensions. And the first step, I create a circular patch. Second step, I cut to form a ring.
Mm-hmm.
And later, I put this semi arc in the left and the right side.
Mm-hmm.
And this is my result of coefficient reflection.
Mm-hmm.
Is working to 2.45 dB
Mm-hmm.
minus 16, and there are this is the another graphs, the efficiency, BSWR. For example, this is the gain, the actual radio, and the current surface. And I don't know if this is possible. Improve this shape for improve the results. I don't know.
Okay, show me your first design. Okay. Your first design that you have shown me.
This?
Yes. Okay, let me take a snip tool and I will give you some suggestions, okay, on your both designs. Okay, your second design looks somewhat new. Okay, and maybe we can work on yes. Okay, let me share my screen and watch my screen.
Okay.
You can stop sharing. Okay. Okay, so you have two designs. Okay, this is your first design. Okay, and you need to vary this length of this CPW ground, okay, to check the bandwidth. Okay, and the other thing, uh, you can create another patch. Okay, like this on this top side. Okay, half patch, and check what is the change in the results. Okay, and you can cut from this side. Okay, like you can cut from this side, okay, and also this side, and check what is the difference in the results. Okay, this is your my first suggestion for this design. Okay, you can publish conference paper on this design. Okay, and for this design we can target journal if you do some modification and achieve more better results. Okay, the first one, if you notice, it looks not much novelty. I mean, you see there is a very small length of this ground plane. So what you can do, you can use CPW. Okay, like this. Okay, this is my first suggestion, sorry, second suggestion for this design. Okay, this is you can try this one. Okay, or if there is no change in the result, okay, then you can remove this CPW and use the partial or full ground plane, or you can use this like ground plane like this on the back side of the antenna. Okay.
Okay.
And the other thing, did you notice, also check what you will not change notice in your design if you remove this patch. Okay, this patch, only keep this one. Okay, only keep this one. Okay. Did you understand what I mean?
Yes, sir.
Okay, yes, I mean like this. If you remove like this. Okay, like this. Okay, if you keep your design like this. Okay.
Okay, I try this today.
Yes, and check how much effect in the results, and you should try this one first, and with CPW. Okay, if there is no change in the CPW, I mean in the results in the CPW, then you can use different ground planes. Okay, try to set at 2.45 gigahertz, but with the new shape too, and with some novelty aspects. Okay, and we can use the metamaterial to make this antenna more good. Okay, or
Okay.
or you can use do one more thing, or you can make like if you have made this shape, you can create another strip line. Okay, in this direction. Okay, and you can make its shape like this. Okay, you can try in many ways. Okay.
One question, sir.
Yes.
The dimensions of the substrate affect the results in
Yes, it depends, but not much. Okay, you can use FR for 1.6 millimeter. Okay.
And another question for I change the length of the feed line. This what is the effect of the result?
Okay. The length of the field line is directly proportional to the frequency. Okay, it means if you increase the length, your frequency will move to the higher frequency. Okay, and if you reduce your antenna, if you reduce your field line, then maybe it will shift to the lower frequency. Okay.
Okay.
I think it is inversely proportional. Sorry, yes, it is inversely proportional. Okay, the width of the field line is directly proportional. The width of the field line is directly proportional to the frequency, and the length of the field line is inversely proportional to the frequency. Okay. Okay, do you understand?
Yes, yeah. Thank you.
Okay, and also uh, you can do one more thing. If you can remove this one. Okay, remove this one and create some bigger patch like this. Okay, as you have designed this. Okay, like you make uh, like this here, here. Okay, and some more if to change in the results, it will become multi-band antenna. Okay, like a leaf shape patch antenna. Okay.
Okay.
Okay, like this. You have a patch. Okay, and you are just like this. Okay, so try this one. Okay, you can copy this, you can copy this one, you can copy this one. Okay, and paste above. Okay, do you understand, what I mean?
Yes, yeah.
Okay, maybe it will help you more. Okay, if you copy this one, this one. Okay, just copy this one and paste above. Okay, make a copy and paste above. Okay, and also on the other side. Okay, then you work on it and show me the results. Okay, when you do. Okay.
Okay. Thank you.
Okay, do anybody want to show anything? Dear John, did you do anything? Yes. Okay, and show me design if you want to share screen. Share your screen, please. There is a distortion from your side, but we are not able to see your screen. You are opening your laptop? Okay.